So again, welcome. So my name is Henk Mulder. I'm the work package leader for public engagement in Enlight Rise. And today I'm going to speak about the way the science shops in our university are organized. I will probably speak for about 20 minutes on this, and after that we have a lot of time for Q&A because, well, you all have different backgrounds. You may want to know different things. So I'll give you the basics of it. So my own background, I'm a chemist by training, but I did a PhD in environmental sciences, and I'm involved as part of my job with the science shops already since 1989. So that's quite a long time. I've also got some experience in helping setting up science shops in other countries. So I know a lot of different structures as well for science shops in other countries. But due to time reasons, I will limit myself in my talk to our university. So first of all, let me explain to you what a science shop is, and I'll explain the name as well after that. In the international network, we came up with this definition of a science shop. A science shop is a unit that provides independent, academic, and participatory, in collaboration with, research support in response to concerns expressed by civil society. So it's really demand-driven. That's an important distinction with other forms of public engagement. We do research for civil society organizations, which we abbreviate as CSOs. So you can call them community groups, civic groups, citizen groups, non-profit organizations. So not for individual citizens normally, with exceptions, but normally not. And we do this by having students do research under staff supervisions, and students will get course credits for it. Well, the good thing about this concept is that students are obliged to get their credits anyway, and teaching staff or professors should supervise them anyway. So there's no additional cost in that sense. The only additional cost that the university makes is for people that mediate this process, the process managers, the facilitators, people like me and my colleagues, which means that we can offer this service free or at least at low cost, and the coordination is paid by the university. And this way we have like a dialogic system in which we respond to the needs of civil society. Then where does this strange word science shop come from? Well, the science shops were started in the Netherlands in the 1970s when students and young teaching staff at Utrecht University were fed up with theoretical teaching. They wanted to do projects, they wanted to do something which was more directly relevant for society. And at the same time, in our society, the first environmental problems appeared. So in no time, there were student groups from Utrecht working together with neighborhood groups on the topic of soil pollution, just to help these people with their knowledge of chemistry. Well, after a few years, the universities decided this was a good thing, and they said it should no longer be voluntary. We should pay coordinators for these projects. And the University of Amsterdam was the first to offer office space to such a group of students and staff. And this office space was an empty shop building. So it used to be a shop. And in our language, we already had a word for Bureau for Legal Aid. We would call that a law shop. So these people were standing in front of their new office and somebody said, well, let's call it a science shop then. And in our language, the Dutch word for science includes the social sciences and humanities. So that's something you lose when you translate it into English. And also the word shop can have strange connotations, like because nobody's paying for something and we still call it a shop. But anyway, that gives you some background of where the name comes from. But it's important to remember you can be a science shop without using the name science shop. So how is it structured at our university? Our university has 5 science shops since 1979. We have one for medicine and public health at the University Medical Center Groningen. We have one in the arts faculty, the science shop for languages, culture and communication. We have one in the Faculty of Behavioral and Social Sciences, which focuses on didactic and educational sciences. There's one in Science and Engineering, that's my science shop. And we have one in the Philosophy faculty. We collaborate a lot with the Green Office, which is in fact like an internal science shop doing all kinds of sustainability projects. And we participate in a science shop that was started by the Hanse University of Applied Sciences, and they teamed up with the municipality and 2 vocational schools and Social Work Groningen. And since like 2 or 3 years, we're a full partner in this science shop. Well, then, of course, most of you will be interested in how are we funding this. So if we just look at the 5 science shops of the University of Groningen, each faculty that has a science shop pays like 0.2 to 1.2 full-time job for coordinating the process of the science shop. In total, we have like 11 people sharing 3.5 full-time jobs. Some of the staff members have other tasks next to this. Some are doing applied research or teaching. Like in my case, I'm also a teacher and a program director for a Master in Science Communication. And some of the other colleagues also do the regular internships coordination for their faculty or department. We have one chairperson who looks after the well-being of the joint science shops, and he is assisted by a communications assistant. And this is paid for by the board of the university, so the central office. And occasionally we get funding for extra activities like European funding, etc., for projects. And this wise the collaboration with the other science shop. In that other science shop, each partner, so the municipality, both universities, vocational schools, bring 0.2 to 2 full-time jobs and some exploitation budget. And WISE gets some subsidy from a national subsidy program. So together with the 5 science shops, we answer like 100 questions from society per year in projects, and about 150 students per year are involved. So given the size of a cohort, about 3% of all the students of Groningen University will do a science shop project once during their studies. And to make sure that we don't lose sight of each other and we can set up multidisciplinary projects as well, we meet every month. We have a joint website, LinkedIn, YouTube, and we have an annual review. And occasionally we organize joint events. To give you some examples of what we're doing, for instance, in the philosophy science shop, they recently worked with the largest regional newspaper because the journalists were worried that their selection of news topic was steered by algorithms in all kinds of social media that they use. And they wanted to discuss like ethics and procedures to deal with this. So this was dealt with students in a course unit called Philosophy Outside the Walls. In the arts faculty, they looked at the internal communication of our municipality because our municipality had a program to not mow certain green areas during the month of May to allow for flowers and bees, etc., to flourish. But their internal communication was very bad about this. So communication students looked at this for the municipality. The University Medical Center Science Shop, they looked at a non-profit organization called Community Support, who helps people that have had like diseases or illnesses to work with their local network and lay carers. And this non-profit organization wanted to know whether they were doing a good job. So it was like a review of their work. So with the WISE Science Shop and the Science Shop in the Behavioral and Social Sciences, they looked at another non-profit organization called Good Neighborhood, who helps people manage their finances in the neighborhoods in Groningen. And they did this together with a learning community with the Faculty of Economic and Business Administration. And our own Science Shop, last year we did like 3 projects on the sustainability in coastal areas. So how to combine tourism, nature, etc., and cultural history. And the Green Office looked at green mobility at the University of Groningen. So that gives you a small taste of the type of projects that we do. And it has impact. So one of our student projects of the students of the Science Shop at the Faculty of Arts won the Ben Veeringa Impact Award last year. And they looked at how municipality at Hogeland, which is a rural municipality, could engage their young adults more in the cultural sector of in the cultural life of the municipality. And the jury was like impressed by the practical impact of the project and the mind shift that the research triggered in the organizations involved and the newly established cultural youth network. So that was kind of a good recognition. So then to give you a slightly a bit more detail on how such a project is set up, I have two examples from our own science shop. They're not very recent, but they're very illustrative of how this works. So we were asked by the city of Assen, which is close to Groningen, because they wanted to set up street lighting in a natural area along a bicycle lane. And this was done for social safety. But they wanted to have these lights to be energy saving and not to disturb the nocturnal wildlife in this natural area. So these were three like design criteria that they gave us. And so they asked us to come up with an advice within 6 months on how to further do this. So we went to the ecology department and asked for a professor and a student to work on this. The professor said, well, since the answer has to be there within 6 months, we cannot do a very in-depth study. We need to take one animal that lives there as a model and study that animal's behavior under the influence of light. So we took the bat as a model animal, and we found a student to work on this. But then the professor said, well, I'm a generalist in animal behavior. I don't have specific knowledge about bats. So we needed somebody with specific knowledge about bats. And we found a small NGO called the Bats Working Group with amateurs who are like studying bats. And their practical knowledge combined with the more methodological knowledge of the professor made it able to set up a protocol for the research. But then we lacked equipment, and luckily somebody knew somebody at a consultancy firm who could lend us the equipment to track the bats' flights. Then the municipality offered to deliver different types of lights, and we started working from a hypothesis that green colored LED lights might do the job, because with green color people can see very well, and it's used at oil rigs not to attract migrating birds. So we started testing green colored LED lights and white colored LED lights at different intensities, and we could put part of the bicycle lane in dark and part of it with different types of lights supplied by the municipality. And we had a student who was a nocturnal animal himself, so he did the testing during the nightly hours. And in fact, it turned out that if you use green colored LED lights at not too high intensity, this satisfies all the criteria because the bats behave exactly the same as in the dark. Well, that led to nice headlines in the newspapers, green light for bats. It was even on national radio, so you can see it's good PR for the university. And moreover, it triggered attention from research groups because they were starting to check on more colors, more intensities, on more animals, and a more thorough investigation on the energy use of street lighting. So one of the important things to see from this project is that none of the stakeholders could have done this alone. So we needed both the professor, we needed the working group, we needed the consultancy firm, we needed the municipality. And together we could develop this knowledge. And at the same time, a student got credits for it. Another example is from our physics department, and we got some questions from local communities that complained about noise during the night from big wind turbines. You can see them here on the picture. And the government said, well, according to our computer models, the official national legally prescribed calculation model, there is no noise at night. So a typical example of computer says no. So we started to look at the model itself. So we really opened the black box of the model, looked at the algorithms, looked at the methodology in it. We had student groups working on measuring the noise. This was like really big with weather balloons and lots of complex data that they had to work on. So in the end, we had conference proceedings, we had papers published on it, we had student groups getting course credits for it. And after 5 years, we could deliver a very complete answer to the government. And because it turned out that their model was suitable for turbines of like 30 or 60 meters high, but not for the ones of 100 meter high, which were the new ones. Because at that altitude at night, there's more wind than during the day, most of the nights in our country. So the turbines turn faster than predicted, make more noise. And at the same time, at ground level, the wind goes down, so there's no background noise anymore. So after 5 years, there was a PhD thesis published on this, and the government accepted our alternative calculation module, and they placed it in the national model. Now, this was a big impact. Imagine that these people would not have had a place to go with their question. This new knowledge would not have been developed because commercial consultants were just using the model. You really needed the scientists to question this model. And at the same time, it's a political decision on how much noise is acceptable. But basically, the university did what it was doing anyway, doing studies, having student groups work, making publications, producing PhD theses. It's not always possible to continue the projects that we start. So in the year 2002, we started the citizen science project because there were small earthquakes developing in our province from the natural gas winning. And people could put crack meters on their walls, could make a digital picture of it, upload it into our database, and the gas company would accept it as proof of damage. But in the year 2007, our then dean decided to stop this project because it was not like high-tech science. So we lost a lot of data, and because the data we discussed every 6 months with the province and the Dutch Mining Board. And 15 years later, the earthquakes became so immense that there's €1 billion of damage. And our university does not have one expert to speak about these earthquakes because the guy running this project had to leave for another job. Anyway, so those were examples. I hope they illustrate a bit what we're doing. Now, we have some criteria to accept questions from organizations. So there has to be some scientific or research element in it. So it's not community building. The results should become public. They should be relevant to a number of people because otherwise you're wasting resources. And the client should be able to use the results. So we call it client. You can use other words if you want to. And the question should not be commercial because then they should go to another entrance in the university. So the university will work with industry and businesses, but through another portal. And if these criteria are fulfilled, there's no financial blockade. So usually the work is done for free. And as I said, the way we can do this is by having students do this for course or diploma work. And in some cases, students can do it voluntary or as an internship, or sometimes if you have money, you can pay people to do it. But the course or diploma work is the most common because that's business as usual. Professors supervise and students obtain course credits. Well, students learn from this. They learn planning, writing, social competence. They get some social and political awareness, and they apply their knowledge in context. And they're learning by doing. So this is like problem-based or challenge-based learning, which in Enlight is very important. Then there are some tasks that we do as coordinators. Well, the first thing is, of course, that you should receive or actively solicit clients and new questions. I can speak a little bit more about that if you want to. And one of the most important steps is to map the problem, to articulate what is the problem behind the problem. So usually we have an intake with an organization. We ask them, well, what is, in your words, what is your question? What's the problem behind it? Did you collect information yourself already? When do you need an answer? What's your own hypothesis, etc. And sometimes it means that if it's a big problem, you can chop it up in different sub-questions. Sometimes that's not possible. And in the end, you can either refuse it if, well, we can't answer it, or refer them to somebody else, or give them a short advice, or formulate a scientific research question. So in fact, it's reverse science communication. You listen to an ordinary question and you translate it into scientific questions. A bit like on the slide with wind turbines, you saw all kinds of difficult physics formula coming from a very simple question. Then in the next step, you have to find a co-supervisor, a student or researcher, and make the project fit in the curriculum. So you have to adapt it to the level of the students. So sometimes it means that you chop it up in different parts for different students, or sometimes there's group work in a certain course unit or minor program or honors program. And sometimes, very counterintuitively, you have to make the project larger than it comes in. And to give you one example, one of our colleague science shops a long time ago was asked to do a study on returning military veterans that came back to the Netherlands after having participated in the peacekeeping mission in Bosnia. And these veterans had a big sense of guilt because they had not been able to defend the enclave of Srebrenica, in which in the end 8,000 Muslim men were killed by the Serbians. And they wanted to have like an inventory of how many of their veterans were suffering from this. But during the intake, the question was, well, what do you want to achieve with this? Well, the ultimate goal was, of course, to find coping strategies or therapies that worked to alleviate this sense of guilt. So instead of having like a third-year sociology student do a survey, they turned this into a PhD project, which in the end interviewed like 1,100 veterans from different peacekeeping missions, and some workshops with the field of therapists and the veterans organization to discuss all the outcomes of it. So it was much bigger. I can tell a lot more about how to find students and researchers, how to adapt it to the curriculum. Then during the whole process, we should maintain communication and do process management. So we take the extra work that then the professor does not need to do. And finally, we help to make a usable presentation, publication of results. We can go to meetings, etc. We can make an inventory of follow-up research teams and evaluate this. Usually in our case, we evaluate with the student, the supervisor, and the organization. And we ask for testimonials. So it's not like forms, but more like a short narrative of 200 words of what they learned or what's the importance of what we have done. And of course, with many organizations, we work for a longer time, so we get to know what works or what doesn't. So to come to a close slowly of my talk, the impact is that of science shop work is that CSOs, civil society organizations, are empowered in their work and actions for the well-being of society and citizens. So it's like stimulating inclusivity in research. For students, it brings motivation because somebody is working, waiting for your results. It gives them valuable employability skills, and it raises some of the social awareness. For research staff, it means that they get data, networks, new angles, and they can tick their outreach requirements. And for science as such, new knowledge is developed, like with the wind turbines, or new research teams are developing. And it's quite often, if you look back or to a question that came in like 10 years ago, you see, then sometimes you see that developed in a whole new research field. So it's like an antenna function as well. For university, it's good PR, like with the BETS example, it's practical education, challenge-based education. It's one way of showing your social responsibility as a university, and you create societal impact because you start from a need. So it's easy to create the impact. And policymakers will just have more data to base their decisions on, not just reports coming from industry, but also reports made on behalf of civil society organizations. So even though it's not for free, it's efficient because it's not like an add-on to university work, but I call it an add-in because it combines the three missions of the university. So it combines research, teaching, and knowledge transfer, like the third mission. And I know it goes by different words in different countries, but most universities have a third mission. And of course, sometimes the timing is a limitation, funding, grants, etc. So it's not like this goes smoothly all over. It's really hard work. And if you look at science shops and science communication, well, we start by listening and asking, articulating, and having people participate. And we have understandable reporting, supporting use, and feedback to the science system. So in a way, this is a very interactive form of science communication. And in a way, it also is implementation of this clause from the Universal Declaration of Human Rights, which basically says everyone has the right to share in scientific advancement and its benefits. So also those without a lot of money. So I already said that science shops are sometimes difficult to, the word science shop is difficult to translate sometimes. So you see here some names that are used throughout other countries. So for instance, in Cape Town, it's called Knowledge Co-op. In Sydney, it's called Shopfront. In Victoria, Canada, they call it the Office of Community-Based Research. Liverpool, it's called Interchange, etc. So I will share the slides with you afterwards. There's more examples from our science shop and international examples. And that basically was my my talk. I hope I didn't speak too long and I could still hold your attention. So I will stop my screen sharing for now. And I'm just wondering if anybody has any questions. You can ask them in the chat, or you can switch on your camera microphone or raise your hand. Yeah, Avril, go ahead.
Hi, Henk. Thank you for a fantastic presentation. My name is Avril. I'm coming from the Institute of Art, Design and Technology in Dublin, Ireland. My question, I suppose, is around the kind of the nature of the beginning. Did this arrive out of an organic need in terms of your own university kind of background, and what kind of strategies did you implement in order to get buy-in from your colleagues within the university as well?
So in the 1970s, this was broadly supported also by our then Minister of Research, who said, well, this is just a good idea. And he called upon the universities to just allocate like 5 jobs to the science shop. So they didn't put funding with it, but it was just considered a good idea for well, showing some of the social responsibility. So in my university, the University Council set up an advisory committee to look at what was happening in Utrecht and in Amsterdam. And they discussed this with the faculties. And in the beginning of the science shops, the first like 15 years, I think, the board of the university decided to support faculties that wanted to start a science shop by paying half of the costs. So all the faculties that wanted to start a science shop could get half of the costs, staff and exploitation from the board of the university. And in the 90s, this changed a bit because of reorganization of university structures. And from that moment on, it was the faculties that were paying for full. But if you speak to, well, to those in power at the universities, you can point out all the different impacts that it has. So I'm a director of education myself, and I have to abide by what we call the Dublin descriptors. I don't know if you're familiar with that, but it describes what a bachelor or master or PhD student should be able to do after graduation. And there's like 5 sets of criteria. There's only one about knowledge, and the other ones are dealing with incomplete information and making judgments about communication, either monologic or dialogic for PhDs. So there's lots of these boxes that you can tick for your program if you have these types of projects in. And also problem-based learning, learning by doing, is a pretty good way to learn. And at the same time, you can show this social responsibility as a university. So, and because the costs that they have are really small for the, well, our university budget is like 700 million euros or so, off the top of my head. It's huge. So paying 3.5 full-time job for people that mediate these processes is not that big an amount, because but we could not have paid researchers for everything. And we survived more or less in our faculty throughout the years with ups and downs. So in 2007, we lost about 75% of our budget because the dean we had back then didn't really like what we were doing, and there were some financial problems as well. But in the year 2021, it was the first time that we put in the strategic plan of the faculty, because nowadays it's more important to have these connections with society. So we exist since 1979, and in the year 2021, we were mentioned in the strategic plan of the faculty. So I hope this more or less answers what you were asking me.
No, it really does, and thank you very much for a kind of very comprehensive answer there. It's much appreciated.
Okay. Any other questions? Just feel free. Well, if there are no other questions, then I want to thank you for your attention and for being here. We'll send you the slides together with a very short questionnaire, because this is the first webinar we're organizing within Enlight, and we want to have a bit of feedback from you guys. And if there's ever anything you want to know more about science shops, we have this the website of the Living Knowledge Network, to which a link is in the slides. And if that doesn't answer your question, just send me an email, because I always like to talk about this. Okay, well, thank you.
Thanks.
Thank you. Bye.
Thanks a lot. Bye.
Thank you, Henk. Bye.
Thanks, Henk. Bye-bye.